Okay, so in this example, we're going to be talking about the Pythagorean theorem, and we're going to have lots of different examples pertaining to the Pythagorean theorem and how it can be applied. So let's go ahead and get right into it, and then we'll start our examples. Now, a quick note, the Pythagorean theorem can only be used on right triangles, meaning the triangle must have a 90-degree angle, all right? So if your triangle does not have an angle that is 90 degrees, you cannot use the Pythagorean theorem. Now, that isn't to say that you couldn't possibly divide up the triangle to make a right triangle. That's possible, but it must have a 90-degree angle in order to apply it, okay? So let's go ahead and talk about the formula for the Pythagorean theorem, and then we'll go from there. So you can see that I have a right triangle right here. I have side A, B, and C, okay? So the Pythagorean theorem states that a squared plus b squared is equal to c squared. Now a and b can represent any side, but it cannot represent the hypotenuse, okay? So for example, I have a here and then I have b right here. You could essentially switch those if you want to, it's not gonna matter, but your c always has to be the hypotenuse, okay? So if you can remember that, you're gonna be fine. A and B, it doesn't really matter which one you're calling A, which one you're calling B, but again, the hypotenuse always has to be C. And here's our formula right here, a squared plus b squared is equal to c squared, okay? Pretty straightforward, easy to remember. Let's go ahead and take a look at our first example. So here's our first example. I can clearly see that I'm dealing with a right triangle because I can see that they have illustrated that right here, okay? And they want us to find the missing side. Well, how do I know what x is right here? What side is that? Well, it's going to be the hypotenuse because it is directly opposite of that 90-degree angle right here. So the hypotenuse will always be opposite to that 90-degree angle. So I know that I'm solving for the hypotenuse here, meaning I'm going to have to solve for c. So I can go ahead and label this triangle now as A, B, and C. And again, A and B, it doesn't matter which one you're calling A, which one you're calling B, just make sure you are calling X, C here, okay? So if I do A squared plus B squared, what is that gonna look like? Well, that's gonna be 10 squared plus 8 squared equal to C squared. Well, what is C? C is X, so I get X squared, okay? What do I do from here? Well, now I simplify it down. Here I'll get 100. Here I'll get 64 equal to x squared. Now I combine, I get 164 equal to x squared. And how do I get rid of this exponent of 2? Well, you have to take the square root on both sides. So when you do that, you're going to take the square root here and square root here. This will cancel out the exponent. I'm going to be left with x is equal to plus or minus the square root of 164. Remember, when you take the square root, it's always going to result in plus or minus. But we're talking about a distance here, right? We're talking about a length. So you cannot have a negative length. You cannot have a negative distance, meaning it's going to be positive, right? I'm picking the positive version. You have to think about this logically, right? So my answer here is going to be x is equal to the square root of 164. And that is not a perfect square. If you take the square root of that, you're going to get an irrational number. So I don't really want to deal with an irrational number because then I'm going to have to round it. I'll lose accuracy. Your best bet here is to leave it just like this here. That way you're not losing any accuracy. And as a result, the answer will be more accurate, right? So there's our answer. So here's our next example. You can see here that they are providing the hypotenuse now. And that's going to be 13 because directly opposite of that is that 90-degree angle right here. Okay, so let's go ahead and label it. I'll call x A, I'll call 6b, and I'll call 13c, all right? So I have to do here a squared, that's going to be x squared, plus b squared, that's going to be 6 squared, and then equal to 13 squared, right? That's c squared. So when I do that, I get x squared plus 36 equal to 13 squared, which will give you 169. And then from here, we have to solve. I have to minus 36 on both sides. When I do that, I get 133. So x squared is equal to 133. So in this problem here, when we take the square root, it's going to result in a imperfect square, meaning if I were to actually take the square root of 133, it's going to be an irrational number. So what I'm going to do here instead is write it as x is equal to the square root of 133. And again, it's going to be positive because we're talking about a length here, right? This is it. Okay, this is my final answer. Okay, let's try another example. Okay, so here's our next example, and they want us to state, is it going to be a right triangle? Now, I cannot just assume that this is going to be a right triangle. I can't assume that this angle right here is going to be 90 degrees. We have to prove it out. So think about how you can prove it out. Think about the Pythagorean Theorem. We know that a squared plus b squared is equal to c squared. So in other words, if I square side A and then I square side B, it should be equal to side C that is squared. All right, so we're going to prove it out that way. So you can call A and B whatever you want. I'll call 9A, and then I'll call 11B. And I'm going to say here, 9 squared, that's my A, right? Plus 11 squared, that's my B, equal to C squared, that's going to be the square root of 198, and then squared, okay? So we know that 9 squared is going to be 81. 11 squared will be 121, so plus 121, equal to, now remember, I have an exponent of 2 here, I have a square root, those are going to naturally cancel each other out, so this cancels, I'm going to be left with 198. So if you add this up, 81 plus 121 will give you 202. So I get 202 is equal to 198. So you have a false statement here. What do you think that's telling you? Well, I have a false statement. That means that no, this is not a right triangle because when I did Pythagorean Theorem, it did not check out, right? If it was a right triangle, this statement right here would be true, okay? But unfortunately, here it is not true, meaning no, this is not a right triangle. All right, so we're just going to put no here, okay? All right, let's try one more example. So here's our next example. This one's dealing with the area of a triangle. Now we know that the area of a triangle is going to be 1/2 base times height. Again, that is going to be equal to the area of a triangle, okay? So think about how you can do this problem. I do not have this height right here. You can see that they divided up this triangle. At the beginning, you can tell that this outer triangle right here was not a right triangle, right? This whole part right here. But they divided it up by drawing in this vertical line, right? This altitude, and that's going to represent my height. So I'm going to say here h, and by putting in that height, you now have a right triangle right here, okay? So what we're going to do is Pythagorean Theorem, and we're going to be able to get h by doing that. Because I have the hypotenuse right here, and then I have either side A or side B, however you want to call it, right here, and then I just have to solve for this other side. So I'm going to go ahead and label everything. This is going to be C, I'll call this B, and h is technically going to be A, okay? So I'm going to put here equal to A, right? So I'm going to say here, h squared, which is really A, right, plus 7.4 squared, that's my B, equal to 9 squared, that's my C. Then I get h squared plus, in your calculator you want to do 7.4 and then square it. When you do that, you get 54.76 equal to 81, right? That's 9 squared. From here, we have to subtract 54.76 on both sides. So in your calculator, you're going to do 81 minus 54.76. When you do that, you get h squared is equal to 26.24. So I know that to solve for h, I have to take the square root on both sides, but I know for a fact that this number right here is not going to result in a perfect square. So I'm going to leave it as the square root of 26.24. So I'm going to say here h is equal to the square root of 26.24. Again, by leaving it like that, you are avoiding that irrational number that will result whenever you take the square root of an imperfect square, and you're going to maintain accuracy this way, okay? So from here, that's half of the problem. The other half now, we have to get the area of a triangle, and we have that formula right here, okay? Now be careful here, when you take the area of this triangle, you're essentially going to be getting this triangle right here, all of this in here, okay? But we want the whole thing. I also want this triangle here. So when you plug it into this formula, 1/2 base times height, At the very end, you just have to multiply it by 2. That way you are getting the other side of that triangle, okay? So in your calculator, you're going to do 1/2 or 0.5. Your base here is going to be 7.4. 7.4. And then your height is going to be the square root of 26.24. So times the square root of 26.24. Okay? And so you're going to go ahead and plug that into your calculator, and then you're going to multiply it by 2. So when you plug that into your calculator, you get the following. You get 18.95. I'm going to round it to the nearest hundredth, okay? But again, that's only for this triangle over here. We want the entire triangle, meaning I now have to take this number right here and multiply it by 2. So when I multiply this by 2, I get 37.91, rounding to the nearest hundredth. So the area of the triangle, we're going to say, is equal to 37.91. Okay? Now they don't give you any units here, but we know that we found the area, so we're going to say units squared. Okay? There it is. There's the area of the triangle. Okay? And this problem is now done. So that is it. That is how you can utilize the Pythagorean theorem. That's how you apply it. There's all different scenarios in which you can use this formula. It will come into play a lot in geometry. But all you really have to remember is that a squared plus b squared is equal to c squared, and that c always has to be your hypotenuse, okay? And your hypotenuse will always be opposite to that 90-degree angle, all right? And then when you're talking about side A and side B, it doesn't matter which leg of that triangle you're defining as A and which one you're defining as B, okay? Just as long as you're calling your hypotenuse C, everything will work out. All right, so that is it. That is how you use the Pythagorean theorem. That's how you can apply it to various problems. I hope that you found the video helpful. I hope that you gained something from it. If the video did in fact help you, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe to this channel. That way you get more math videos in the future, and I'll see you in the next one.